morning, everyone. My project will be focusing on, well, the name of my project is DINR, or DINR, and it's a detection integrated nano-array rover. I want to first thank all the mentors for their support, which is Dr. Austin, Dr. Coughlin, Dr. Horton, and Dr. Staub. This is basically the concept of my design. This will be the camera, this will be a sensor I'll describe later on, and some of these operations. Approximate dimensions of this is, I put a scale to it, it's 40 centimeters. So it's a fairly small rover. DNR rover technology is going to be primarily used for chemical, biological warfare detection. We do have federal and actually international laws that some countries participate in, but there's also groups that do not participate in that. So this technology will be helping prevent sort of disasters that could occur from that use. One of the quotes Dr. Coughlin gave me is DoD is currently in need of reliable and compact detection device for VX nerve agents. So the purpose of DNR will be to fulfill the needed gap to develop the current chemical and biological warfare in a reliable, compact, technologically advanced and semi-automated device. If the DNR can successfully determine the location and the content of the given AO or area of operations, then the appropriate countermeasures can be taken for the casualty to prevent casualties of the operation area and proximity. Also, I read this book. It's called Nanotechnology in Chemical and Biological Defense, and it helped me verify with Dr. Coughlin and the need for this type of invention. There's some steps, which is going to be organizing a team for development, then conducting preliminary research and creating an RFP, negotiating budgets and deadlines. Then we're going to be moving on to step 2, concept development, selecting appropriate sensing technology, synthetic bonding elements on that technology, and adding optimized sample processing and navigation of the hardware. Also, the later part of that would be navigation and analytical software, developing individual processing and synchronization program, developing self-navigation and recognition program, and then developing a program that secure data encryption and transmission. Just so that you have a scale or in comparison to what scale we're working on, we're going to be working in the virus scale. This is how small this technology will be implemented. This is one of the examples of the sensory I'm planning on using, and I'm using VX Chemical as the example here. We'll have a quartz crystal microbalance for chemical agent. We'll have a ligand right on top of it. That'll be synthetically ligand, which is currently in research. What that material would be to bond the VX molecule to it. And this will cause once the VX chemical molecule bonds to the crystal, we'll be able to measure the mass, the increase on that surface, which and if you have a whole array of them and they bond, once the crystal gives off that vibration, we'll be able to measure that vibration. And with a quantity of them, we can have the intensity of that vibration to measure. We know that the molecule, the VX molecule with a molecular mass of 267. So we can generate software and produce a program that will evaluate that molecule. Also, one of the other technologies I want to use for biological part of the detection is quartz crystal microbalancing with biological agents. We'll have quartz crystals that be spotted with a synthetic oligonucleotides. The block of this chip, I'll say, is going to be submerged in liquid. Once we process a sample, and I'll get into that a little bit later. Once we process the sample and isolate RNA and then isolate only the mRNAs, we'll perform the reverse transcriptase and generate a stable cDNA. Applying the cDNA and on the DNA QCD block and begin hybridization. Once we flush out the unexpected fragments after that process, we'll drain that liquid or have something absorb that liquid, and then we'll measure the vibration frequency produced by the quartz crystal. Because we should have some bonded DNA samples or gene expression in that. There's some additional equipment that will be needed to be on the rover, which this is not a complete list. There might be more, but Vortex Genie is one of them. Centrifuge machine, which is going to be at a lot smaller scale. Electromechanical pipettes or some kind of transfer and movement of that sample, and solvents and buffers solution. This one is still in the works, but I'm going to be going with the carbon nanotubes, electrochemical nose. I'll be using, this is my conospherical nose here. It's intentionally misspelled like that. But nose would be it would be like a trained nose that's going to pick up certain molecules surrounding in a distant area. This is going to be one of the features that are going to enable the rover to make intellectual decisions to where it's going to go. Because there's also looking forward to utilizing nanotubes. Okay, here's where I was talking about carbon nanotubes being electrochemical nodes. So we know, like for example, we give this machine a direction. We tell it, okay, we want to check out this region or this area. And we send it, let's say this is where this arrow showed. We're sending it in that direction. We don't know exactly where the threat could have been or the biological or chemical weapon could have been used, but this rover could go in that direction, and once it picks up with that sensor, any chemical or chemical signal in the air, it would actually navigate towards the maximum area, and it would draw its samples once it reaches that area.
It's like a sniffing dog, huh?
Yeah, yeah, exactly. So the DNR conceptual optical navigation is going to be, we're going to be using a Litro camera inside that. The advantages of that is there is a team of scientists that was able to measure object distance just from the images taken by this camera. We can do calculations using light field special refocusing principles and Gaussian formula, and we can determine the distances that on each part of that image, and then we can assemble like a 3D image and navigate. Some of the sample is like, for example, the light, the way the light reflects, so we can know this distance from this part of the apple, from this part of the apple, because all this is getting transferred into a lens. This is a multiple light field lens that picks up various light angles coming into it, or intensity. Next would be, who would be interested in this? Of course, the Army, Navy, Department of Defense, Defense Advanced Research, Project Management, or Agency, Strategic Command, and National Security Agency. Also, there could be agencies and law enforcement and a national
securities like FBI or private sector as well. These are the sources. This is not all of it because there's still a lot of conceptual things that I want to get to. I'll just describe briefly. I'm working on, let's get to the front. There's also, I'm working on the gearing mechanism to make sure that I have the maximum capacity available inside this rover. And this is infrared. I'm working on the infrared spectrometry, which is a mobile infrared spectrometry, which is, this is a hub that will go over a sample or a certain spot in the ground, and it can draw it up, adding a liquid and then picking up the chemicals from either dry liquid or some other type of sample. So this is it. I'll just go to the front page.
Okay,
Okay.
thank you, Igor. So, questions now, and it's quite long. Dr. Maybe has a question.
Yes, in a few words, what is the mechanism by which a carbon nanotube senses the presence of certain molecules?
Well, I'm still working on researching because there's a lot of little details that you need to get right to have a right nanotube. It's the coatings, what you're going to use on the surface. Am I going to use the ligand to pick up certain molecules? Am I going to have different nanotubes that are going to pick up different molecules to try to assemble that?
The key word there is pick up.
Pick up.
Again, that's getting to mechanism. Just in a few words, how, if I have a molecule, how is it sensed? What is the mechanism of sensing?
Through electrical current that it sends through that nanotube. It's really hard for me to explain that. That's why this part was kind of left out.
Okay, it may be hard, but that's really, really
Yeah,
important.
that's definitely being researched, and I'm going to provide that in the next presentation
Good.
on more of the details.
Good.
Also, the size of it, how is it gonna like navigate terrain and stuff, like different terrains? Because it's only in 40 centimeters.
Well, that's a good question. That's where that camera comes in, the LITRO camera. It's going to be helping the rover avoid some of the obstacles that you might think of, which is more common. Like, for example, if there's a big rock, right? This camera and the analytical software behind it is going to allow this rover to avoid that. Instead of just coming up to that rock, hitting it, and then backing up, and then hitting it again. It's going to be avoiding those kind of situations. It's a semi-automated, so it's not a fully automated rover.
Dr. Hussein, oh, okay. Tevin, come on. That's okay, that's okay. I didn't see you.
Considering the size, have you considered, for hard-to-reach areas, attaching it to some sort of levitation
Levitation?
propeller?
Oh no, this what this general idea is, if you look at it, I did have cutout sections. So this, everything is going back into the rover. So it's very compact, and this could be like airdropped, and there's not a lot of things sticking out. All of this can telescope back into the rover. This can fold down so that you can deploy this rover anywhere you want. And answering your question is, this is just an on-ground, it's not levitational. And it's for, like, say, let's bring up a scenario. For example, if we take a battlefield and we have lost communication for the battlefield, and we know that area of operation for a certain group, we could send one of these rovers instead of risking sending personnel into that region because we don't know what's out there. We could send one of these rovers in there, and it could analyze the situation, give you feedback, imaging, and provide all that intel back to the command. And it can actually navigate and pick up samples. So for example, if there is something laying on the ground, it could come up to that, draw a sample, and analyze that sample for certain content. Maybe it's biological, maybe it's chemical. That's what this device is really for. It's just to go into places that we don't want to send a human into. There are technologies out there that are that will be competing with this, which is it's called a smart car. It's a little device that has a paper kind of sampling that you can add a sample to it and then plug it into that device, and it's going to send to command what kind of chemical and what kind of biological weapons used. But of course, the soldier has to be the one that's putting it in there. What is the response time? Maybe the soldier is not going to be thinking about, oh, I got to send this paper to command. I got to get out of here, you know? Maybe something like that, or maybe they won't be able to do that. So this device is really like the scout that's going to come in and go into the area and evaluate it. And then that's why it's a little bit semi-automated, because we don't know how, where exactly this happened. Or maybe sometimes we'll know where exactly it happened. But in the times that we don't know exactly where the exposure or where our personnel is, let's say, in proximity, and we want to make sure the area is clear, we can send one of these rovers in. And if it detects anything, because it's going to be self-navigating through the region, then we'll be able to know what's going on.
Area card?
Mine is not like a question, but a comment on your, one of the things that I noticed. When you explain how this system works, you talked about how frequency changes as the mass on the tip
Yeah.
changes. That sounds a lot like how an AFM works, atomic force microscopy. So I would advise maybe next time, you can compare.
Okay, atomic force.
ASM.
Okay.
The nose only senses if there's something there, right? But it doesn't
Oh,
distinguish between.
this part right here?
The conospherical nose.
Oh no, this nose is well, it's a sample drawing, but in addition, one of the areas that I wanted to expand on was making this as a hub that's gonna go over something and it isolates it, and then we can heat it, or let's say add some liquid to it if it's a solid, and then we can heat it and pick up those fumes and evaluate them.
So the fumes go then to.
Yeah, like a little
PCM.
vacuum, and then it'll get processing. It'll include like an onboard infrared spectrometer.
And do those sensors get clogged up quickly? I mean, do you have to refresh them or just replace them?
Yeah, that could be one of the problems, but I am looking forward to not having anything that's going to be touching the actual sample. I want to have as much as possible to avoid any contamination of the equipment being used. So,
All right, that's really very interesting, very broad scope.
it's still very.
Again, yes, and I like the idea that you already laid out, what are the possible steps in getting into the concept. So, given that, out of those 3 steps, you have 3 in there, or 4, I think, that you have to go into, and it's a long-term thing. Which of that is feasible at the end of the semester? At which point are you gonna be, because right now, it seems like you're already in the concept, so there's no question about that. So
Well-
my question is, which next step do you think are you gonna be able to get into?
I think assembling a team could be one of the steps that could take on
A
this.
team of
Because this is
faculty, of experts like
team
you
of
right now?
experts, yeah, because not a
You
team of
have the
students.
experts right here, right now, which is good.
Yeah, a team of experts would have to be on this, because, I'm only scratching like the surface of what's
Yes.
out there, and I'm already fascinated by just scratching the surface. But I'm sure specialists that have been in this field for a long time know what they're doing, and they would tell me, oh, this is not the way to do it, what you're doing is kind of like this. This is the direction you should go to.
Brilliant idea, though. Brilliant idea. I'm really hoping we can get to that. So, any other comments? Yeah. So that's gonna be James Bond's next gadget, huh? All right, Eagles, thank you.